And as we still haven't finished debugging this program, let's just go to the source file, right click and go to Disassembly View. Let's turn on, in this Disassembly View, I tried to simplify it since earlier doing our laboratory work, but now I'd like to see where my actual source line appear to correspond to this disassembly. So I'm going to right click and so show source code. In most systems after you install Visual Studio, this will be turned on by default. So I'm just going to turn this on, and now I can observe that this is my line of code that corresponds to our string length, and this is the actual assembly code associated with this. So let's copy and paste this to preserve it, to use it later when we try to work on our own version of this program. So I'm just going to use multi-line comment and copy and paste this line, which corresponds to calling string length. We will discuss it in detail. Okay, so the next part right here is this call that corresponds to a string copy, the series of instructions that correspond to string copy. So let's copy this also. I'm just going to say copy. It doesn't give me an option to copy, so I'm just going to press Ctrl C to copy this. But it should be visible that here's the call into string length. Instruction calls this in this function defined in this header of the C standard library. And then we also have a call into string copy, which looks a little bit strange right here, but this is due to the internal implementation of Visual Studio C++ compiler. That's okay. We will we will be able to simplify this. At this stage, I'm just going to save this and debug, stop debugging. So my next step will be to go to View, Solution Explorer, and remove Main Cpp from our source files. Just like this, I say choose or remove, choose delete to permanently delete. I don't want to permanently delete, just remove from the project. So remove, and it just disappears. Okay, so this is my file under my project name, under source, main. I'm just going to bring it back. I don't want to have it closed. I'd like to use it as a prototype for assembly code to write. So the next step will be that the usual first step, if we want to replace this by an assembly program. So let's go to project level and change build dependencies, build customizations, and again select MASM to bring it as a tool into our toolbox. And so then we can just take a copy of any of the previous projects. We may use this section assembly code that we've used earlier in our presentation. I'm just going to copy this week 12 ASM and save it in my M12, the current project source subfolder, copy and paste, and rename it to be M12. Then of course I can just drag and drop and show it, and here I'll just reduce it to a very basic set of segment directives and delete all of the instructions that we tried earlier. Just keep the main procedure with the return instruction, and that's about it, just a bare bone version of this program. So now, of course, we can go to the source files. Let's save this and let's go to the source files and add existing item, and this time we will jump to the source subfolder and select M12. Okay, so now we have M12, and this is now our source file, the only source files right here. I want to check its properties. Normally after adding MASM and then including one of the source files with ASM extension, it will configure it to be built with assembler. So I go to properties, and you can see that the file is already configured to use Microsoft Macro Assembler. If you check this and it says does not participate in build, just make sure that you select the right choice right here. Okay, so I'm going to cancel out of this. In fact, why don't we build it right away? Just build, just to make sure. Since we changed the source files, let's just first clean everything from the previous build, and then just build fresh like this. And you can see that it works pretty well. Everything is clean. So now we can close this, and we no longer need, hopefully, our Solution Explorer, and we can just use our go to New Vertical Document group and use this disassembly as a prototype for our lab, which is asking us to write some assembly code capable of doing this and this, right? Measuring the length of this the string, and then copying it to a different place. So let's first deal with our variables. Of course, the first thing is the string hello. So of course I prefer to keep it in a constant data segment, so we can say this is our source, and of course it's byte, right? And we use hello, and we need 0 terminating character. So this is just an allocation of the string of characters. Then we can use destination, and of course it's very similar, also byte string. And we're going to say that we're going to use 80 characters, right, and 80 duplications of 0. Okay, so this is all initialized, and this is our destination for copying characters. So the next step is to discuss what is happening. So first, let's take a look at this. And here, what we're loading into register EAX is the address of string hello. In other words, the address of the first character. Why? Because source is a pointer. Source is a pointer variable. Its type is pointer to constant character. And so this variable already contains C++ compiler already places the address of this character into this variable. That's why here what we do is that we go to this variable and we bring from its memory the address to which it's pointing to. In our case, what we're going to try instead, of course, we know that we don't have a pointer, we have a direct memory operand source. So what we are going to do instead, we're just going to bring in the offset of source, right? Because we know that this string of characters is located in global data segment, global variables data segment, and so we're just going to grab its location from the data segment. So that's pretty standard. In this program, there was a pointer variable. In our program, we don't have pointer variable. We just have a label which contains address of these characters, and that's all we need. We just need to find out what is the address of this relocatable string, because it's a relocatable data segment. That's how we do it in assembler. The next thing, we push EAX. We haven't talked yet about procedure calls, but this is how typically strlen function expects the address of the string to measure the size of it directly as a parameter, and parameters are pushed on the stack. So what is going to happen is that before we make a call, there is a stack segment, and we're basically, so our ESP register ESP is pointing to the top of the stack, and push instruction will take the content of this register and store it in the stack area, and will increment register, actually decrement register ESP by 4 bytes, because EAX is 4 bytes. And this parameter will end up to be in the stack segment. This is stack segment right here, right? So this is our stack. And when we invoke procedure strlen, this procedure will be looking for this argument source right here. So this strlen procedure will be expecting to find the address of our string, which is string hello, right? At this location on the stack. We're going to talk in details about stack operation instructions dealing with stacks when we talk about procedures and the stack segment. But for now, this is just how simple it is to pass parameter to the string length function. And the next thing that we're going to do is just basically do this. We're just going to use this instruction, string length. And that's how simple it's going to look like here.